In this video we are going to be calculating tide times and heights for non-standard ports, and the non-standard port that we're going to be looking at, or that we're interested in for this particular example, is Tewantin. The date in which we're also interested is today's date, the 9th of February 2017, and the given time for part C is going to be 1000 hours. So this is also, if you want to fill this in, going to be our 1000 hours. Okay, so to start filling in box A, what we require are the standard port times and heights regarding the standard port of Tewantin. Now the standard port of Tewantin is Noosa Head, and today's date we said the 9th of the 2nd 2017. What I need to do is put some data into this table, and I get that data from the tide timetables for Queensland 2017, and this is my standard port, Noosa Head. This is the month in which I'm interested. Today's date, the 9th, Thursday. Okay, so I'm simply going to copy this information and put it into the box. Yeah, we'll do that relatively quickly. It shouldn't be an extremely long, arduous process. 0026 0657 1325 and 1912. Just check them to make sure that you haven't written them down wrong, because if you write them down wrong here, it's going to carry throughout part B as well as part C. So you need to be careful that you enter these in right from the get-go, and that we're not entering in values for a different date. Alright, once we're there, we've finished box A, so I'll put a little tick next to it, and we move down to box B, which is times of high and low water at the non-standard port now. So the non-standard port is Tewantin being in place, so we can go ahead and fill this in with regards to the place and the date. The date is still the 9th of the 2nd 2017. The next thing we should do is note the heights. Okay, and you'll see this is lower than this, and this is lower than this, therefore we have a low, a high, a low, and a high. You don't have to write them in, but it will possibly help you with regards to identifying the tides up the top of box B. We do that the same for both of these because they're referring to the same tides, just like so. So we simply copy this from this one, and we can start filling in box B. What we're required to put in is the standard port times regarding the standard port, which is up here for Noosa Head. Okay, and the standard port times are located in this column. So we're simply going to rewrite these four values across the page, leaving enough room for 1, 2, 3 lines of working. So we'll go ahead and do that. 0, 0, 2, 6, 0, 6, 5, 7, 1, 3, 2, 5, 1, 9, 1, 2. Just like so. We then need to get this value, the average time difference from table 2, columns 2 and 1, which is referring to this particular information. Okay, now we've got table 2 here, columns 1 and 2 refer to these time differences for the high water and time differences for the low water. If I scroll down to to Tewantin, which is right here, okay, dotted line between all these bits of information, you'll see that I've got a plus 107 for a high water, which means I have to add 1 hour and 7 minutes to every high water, and I have to add 1 hour and 49 minutes to every low water. So I go back to my table and I start to fill them in. Note I have a low water first, and we said low water we need to add 149. So I'm going to add 0149. And I'm going to show that with a plus. Okay. For a high water I'm going to add 1 hour and 7 minutes. Just like so. And I'm going to also plus. Now, if you're wondering why I'm adding these things, it's because it states that with regards to these values, this is a plus as well as this. If I zoom in, you should be able to see that a little bit more clearly. We got our this in, our plus 107 and our plus 149. Okay, so that's where they come from. So once again, I've got a low water and I have to put my 0149, 0149, and finally my 0107. And as I said, these are all going to be adds. If I add these together, 9 and 6 is 15, carry the 1, 7, 1, 0. 7 and 7 is 14, carry the 1, 5 and 1 is 6, 6 and 1 is 7, and 0. 9 and 5 is 14, carry the 1, 6 and 1 is 7, 3 and 1 is 4, and 1. 7 and 2 is 9, 1 and 0 is 1, 9 and 1 is 10, carry the 1, 2. So what we've done there is added those two things together, and you'll note that these values right down the bottom are our adjusted times. Note that these are our minutes, and for several of these values, this one, and this one, the minutes exceed 60. 64, 75, 74, which means I have to convert the minutes to hours and roll another hour across for each of these ones. So this I could express as 2:15. Okay, 1:75, we take 60 minutes from this 75, move it across another hour, leaving us with the 15 minutes. Likewise over here, we have to roll across another hour, leaving the 4 minutes. Another hour, leaving 14 minutes. And this last one we can leave it as it is, just like so. We then need to go and do our standard port heights. Okay, now that's from A, which is this up here. So we're going to simply put these values now across the top of this table. So 0, 3, 6. This line obviously represents a decimal. Same with this one, and that one. 211, 050. 162. The ratio we need to then fill in for this particular piece of work in here is going to be taken from table 2, column 9. So here's table 2, and we're going to look at column 9, which is this ratio, column 9. If we scroll down to Tewantin, the ratio for Tewantin is 0.31. Okay, which means we have to multiply all of those heights by 0.31, which is what we are going to go and do. 0.31, 0.31, 0.31, 0, like so. We're then going to put in a multiply so that we can explicitly see what we have to do to those two values. And this is where you need yourself a calculator. If you multiply these values out, it makes it a lot faster than doing it on head or just working it out with pen and paper. So 0.36 by 0.31 is the one I have to do first, which is equal to 0.11, approximately. Okay, and just round it to 2 decimal places. 2.11 by 0.31, 0.65, and 0.5 times 0.31 equals 0.16, and 1.62 by 0.31, 0.50. Now I have to put another value under here with regards to this adjustment, and it says once again from table 2, but this time column 10, and if I bring this across you'll see here's my column 10. If I we'll come down to Tewantin, I've got this value of plus 0.09, and that's for every value. So I'm going to have to add 0.09. 009, and finally 009. I'm going to add those values to the previous thing we just calculated. So I'll simply do this in my head if I want. So all I've simply done is add these two values together, these two, and these two to get the final secondary chord heights. Now don't be too confused with regards to, or concerned that these look different to that, okay? They should, because it's an adjusted height, okay? Now we're up to, finally, box C. And this is the hardest of all three, and what we need to firstly do is put in this value of 1000 hours, which we have, but we can also do it several places in this box C. So I like to put it into every single place in which you would expect to see it straight up, so I don't have to worry about it in the future. Okay, and time required is the last 1000 hours. So now we can go and fill in the place. Now the place, this is referring to the non-standard port, being Tewantin. The date is the 09/02/2017. Now the nearest high water refers to the nearest high water to 10 o'clock. And if we go up to our information, we've got 2 o'clock in the morning, 8 o'clock in the morning, 3 o'clock in the afternoon. Okay, so 10 o'clock's going to lie between here, or somewhere between that high and that low. Now if that's the case, the nearest high water will be this one, which occurs at 0804. So if I write 0804 into the box, I then simply need to determine the difference between these two, okay? So the difference between these two. And it says approx. So we don't have to be bang on the money. What I mean by that is the hourly interval between these two is 1 hour and 56 minutes. But realistically, we could just call this 8 o'clock, okay? Because 4 minutes is not a substantially big value with regards to what we're going to do later on from with regards to pulling a piece of information out of a graph. So this isn't going to affect our result too much. So you can just simply say, if you would like, that the approximately hourly interval is about 2 hours. Okay? That's fine. Approx. The nearest high water occurred at this time, 804, but the height in metres is represented by the 0.74 in the column below it. So we've got 0.74, and the nearest low water we said occurs over here, which occurred at 3:15 approximately, and it was 0.25 metres. Now the range between those two tides is not very big at all. So what we can simply do is take those two things away from each other to get our range of 0.49, or approximately 0.5. And then we can go about getting this height from the graph, okay, which is what we're going to look at in a second. The height of low water, we've essentially noted that we've got our low water here, nearest low water, and the height is 0.25. So likewise, 0.25 gets written in again, and the height from graph 1 or 2 now needs to utilise these two values, being the approximate hourly interval and the range, the tidal range. So this is what we do. With those numbers, we locate the approximate hourly interval on our x-axis, which is here. Here's our 2, plus or minus will give us the same results. We then need to note that our range is 0.49, which is very close to 0.5. Rounded up to 0.5, it's going to save you some time. And if I go to my range curves, you'll see a 0.5, a 1, a 1.5, and so on. This is the 0.5, which is closest to my 0.49. So this is the curve that I'm going to use. And I simply match up the two with that range curve, and I go across to what it is suggesting on the side, which in this instance is approximately 0.4. So that value there is going to represent my height. What I then need to do is add these things together, and I will get my height of the tide at 1000 hours for Tewantin. So I simply add these together. Put in your metres, and just to rationalise it, the highest tide for that day was 0.74 at Mana Point. At Tewantin, sorry. So at Tewantin, the highest tide at Tewantin was 0.74, and that occurred at about 8 o'clock. So 2 hours after the high, you'd expect it to be dropping to low. So the tide would be less than 0.74, but bigger than 0.25. And if we look at this number, it does fit in there nicely. So this is definitely a ballpark figure, and I could be relatively confident that that's the correct answer as well. That's our process for calculating the tide times and heights for non-standard ports, and in this particular example we have done so for Tewantin.